Good day, ladies and gentlemen. We are at 9-6 Misleading Graphs and Statistics. We are going to do a flipped classroom lesson today. And just a quick reminder that you can access all you need to access it, since it's been a while since we've done a flip. You can access everything you need in Chapter 9 Data and Statistics, and then go to Misleading Graphs and Statistics. All of your homework is here, but you already have a copy of that in your binder, or will have a copy of that in your binder. And then you also have your Explain Everything assignment, which will be due tomorrow, in which you need to create an Explain Everything video with 2 slides. The first slide has 4 to 5 takeaways, and the second slide is a video demonstrating that you understand the concept in a real-world situation. Here we go, back to the lesson. Quick lesson run through. I'm actually going to use the PowerPoint again because of the visuals are much better than what I can draw. So we're going to skip right on past this. We're going to skip right on past the warm-up, the problem of the day. Here is your I can statement. I can recognize misleading graphs and statistics. And here is just a little note. They're used to persuade, graphs and statistics are used to persuade people to buy something, to do something. And there are very clever ways to persuade you to do things by misleading you. So we'll give you a couple of examples, and then your job for your assignment and for your real-world situation is to identify these misleading graphs and statistics and learn what they're really trying to tell you. Here's our first example. We have stock value of something starting in 1990. It doesn't really tell us what it was. And it shows that the stock is rising between 1990 and 2000, which is great. And then it rose to over double than what it started with in 1990 and 2010, which is wonderful. And then it shows 2020, which is still a ways away from current day. And it shows that the stock is going to actually have tripled by 2020. This is misleading because there is no way you can be sure that the stock is going to triple. It is just a forecast, or it is just a prediction of what the stock's going to do based upon past performances. Now, they may have good information that is making that prediction, but you can never be sure that your stock is going to continue to rise. So this would be an example of a stock market analyst or a stockbroker trying to get you to buy their stock using data that really hasn't happened yet. Next one would be school play ticket sales. It shows, if you just look at the graph, that the 6th grade sold way more tickets than the 7th grade, about triple the amount as the 7th grade, and probably almost triple the amount as the 8th grade. But when you truly look at the graph and you truly look at the data and you look at the X and the Y axes, you can see that the 6th grade sold about 120 tickets. You can see that the 7th grade sold about 100, and you can see that the 8th grade sold greater than 100. I don't exactly know the number of tickets. So the 6th grade technically only sold about 20 more tickets than the other 2 grades, but yet it shows that their graph, or their bar, is about 3 times bigger than the 7th and 8th grade. The reason this is misleading is because they use what we call a breaker, B-R-E-A-K-E-R. They used a breaker to represent a whole bunch of data between 0 and 100. Breakers are used to get to the data values that you actually need to get to. Because the 6th and 7th and 8th graders sold between 100 and 120 tickets, they didn't want to start at 0 and go to 10 to 20 to 30 to 40 to 50 because the graph would get gigantic. So they started at 100, showing that there was a big break in the data between 0 and 100, and then the gaps between 100 and 110, 110, 120 were consistent. So a breaker is something you always have to look for on a graph to be sure that you are really reading the data correctly. So in this case, it's misleading because the 6th grade really didn't sell 3 times as much as the 7th grade and the 8th grade. They sold about 20 more tickets. But again, the breaker will mislead you unless you pay really close attention to it. Let me close the ink, and we're going to move on. So that would be a second example of misleading statistics. The scale on this one, shoe sales. We have brand A, we have brand B, we have brand C. It looks like they have sold about the same amount of shoes, but in this situation, the data is condensed really closely together, but we have gigantic numbers we're dealing with. Whoopsies. Let me go back for a second. with me. We are dealing with big numbers such as 20,000, 40,000, 60,000, 80,000. If you look at brand A, it looks like they've sold about 50,000 shoes. Brand B has sold about 45,000, and brand C, they're well above 50,000. Even though they look like they sold the same amount, we're talking about a difference of thousands because we have really condensed data. The graphs are the labeling of the y-axis is consistent. There is no breaker, but we're dealing with each gap of 20,000 shoes. So condensed data would be another way that you can manipulate people and their thoughts on data. Moving forward, this graph is misleading. If you take a look at it and you also read the text here, it is the percent of return on investment, and we got 10%, 20%, 30% going up on the y-axis, and we're talking about years across the x-axis. If you look at year 5 and you look at year 6, they have not happened yet. It is a projection. This is showing that they think, based upon previous performance, that whoever's selling this, that the stock is going to continue to rise at year 5 and year 6, but really year 4 is where we're at right now, and it's just a prediction. It's a projection. They actually said it was a projection, but they only used a small little key and asterisks, again, hoping that people weren't going to pay attention to the fact that it was a projection. Here we have another example of a breaker, preferred juice flavors. It looks like all of the juice flavors are pretty close in numbers, from 142 apple to 148 grape, a difference of only about 6, but yet it looks like over twice as many people prefer grape to apple when it really is a total of 4 people. Again, the breaker manipulates your thinking on what truly is the case with this graph. This graph is so compressed, another compression graph. You can take a look at that in your notes. We've already talked about those. Last thing I want to look at is wording of statistics. Example A says 4 to 5 dentists surveyed preferred ultra clean toothpaste. It looks like almost every dentist prefers this toothpaste, but if you only survey 5 dentists and 4 of them prefer it, the next 10 dentists that you survey may say, no, I hate that brand. So again, you have to look at how many people were surveyed and what the size of the sample was. Second one, B, shopping at Save A Lot can save you up to $100 a month. It sure could save you up to $100 a month if you bought everything that had a savings amount. Usually when you go to a grocery store or a store, you don't buy everything. But if you did, you would save about $100, even though it costs you about $10,000. Last example, Sam scored 43 goals for a soccer team during the season, and Jacob scored 2. As the text states, Jacob may be a defenseman, Jacob may be the goalie. Goalies don't score all that much. Jacob may have been hurt all year long. Jacob may have scored 100 goals last year compared to Sam's 40 goals last year, but in this year, if he was hurt and didn't play much, that would be a major difference. So lots of different ways of looking at that. That is what I have for you. Good luck.